Hey guys, Rudi here, back with another CSSE1001 and 7030 tutorial solution. This week we're going to be looking at the week 4 tutorial, Abstract Data Types. So this week is mostly about manipulating strings and using loops, honestly. And now we're actually going to get into a bit of problem solving now. We've equipped you guys with the sort of basic tools to get these problems solved. And now we're going to dive right into it. So these first couple are all about DNA sequences. Okay, so DNA sequence can be represented by a string made up of the characters A, T, G, and C. The length of a DNA sequence must also be a multiple of 3. And then we want to write a function, isDNA, which takes one thing in, which is a string, and gives us true or false back, whether it's a valid DNA sequence. So we can see here we've got two clear conditions, right? Every character must be an A, T, G, or C, and the length of a DNA sequence must also be a multiple of 3. Okay, so straight up, we're probably going to want to be looping over every character in whatever sequence we get here to determine if each of its characters are A, T, G, and C. So the easiest way to do that is with a for loop. Okay, so if we want to loop over string, for instance, we can say for C in string. Okay, and now this will set up a loop for us, because this C here will be assigned to be each sort of consecutive thing in the string. So what exactly do I mean by that? Well, let's just get the shell up. Okay, so if I've got some variable, no word, and I go for some variable name in that thing, that string we've got there, let's just print out var and see what's happening each time we go through that loop. So we can see that each time we go through the loop, var is getting assigned the next thing in that loop. So initially the first thing was W, so var was W, then the next time through the loop it was O, then R, then D. Okay, so whenever we have some sort of sequence or something that we can iterate through, right, for instance a string or a list or heaps of other things that we'll come across in later weeks, we can use a for in loop to really make that process a lot easier for us, right, as opposed to trying to set up some sort of index loop where we have like 0, 1, 2, 3, and then count through the string that way. Okay, so for every character in our string, right, that's why I typically use C for these things. You might often see char. It doesn't really matter what you call this, right? It's just a variable name, but I'm going to use C for most of these. So what we want to know is that if every character in the string is an A, T, G, and C. Okay, well there's a fairly straightforward way of doing that, right? We can just be like if C equals A, or C equals, I'm actually going to merge this up, see if I can, actually I probably won't be able to fit it on one line anyway, so or C equals T, or C equals G, or C equals, what was our last one, C. Okay, cool. So what have we got? If the character is one of these ones, then it's a good one, right? And otherwise, so what do we have here? Good character, and here we've got a bad character. Bad char. Let's be consistent here. Okay, so I've seen a lot of stuff where people come along and they go, okay, it's a good character, so we're true, right? We want to have a good sequence, and if it's a bad character, we want to have false. Okay, now that might seem like a good idea, but let's just run this and have a bit of a think about what's going on here. So is DNA no cat. Oops. Okay, cool. So that one's supposed to be right. So, oh, whoop-de-doo, it's working, right? But what happens if I put a whole bunch of other illegal characters at the end here? Still seems to think it's true. So if we look at this pattern here, regardless of whether we take the if path or the else path, oh god, on this if statement here, right? We're still returning no matter what. So this means we essentially don't really have a loop here, right? We're just taking the first character in our string and returning every single time. Okay? So we don't have a loop here. We're literally only looking at the very first character in the string. And that's why, since the very first character is good here, either way we're getting back a true. Okay? So this isn't a good structure, and it's something that you should never do, right? We should never always return out of a loop, okay? Because then it's not a loop. We're only looking at the first thing. So let's have a bit of a think about this, right? If we have, I suppose the question is, how many letters do we have to look at to know if our whole DNA sequence is a good DNA sequence, right? Do we have to look at one letter, at two letters, at three letters? Not really, right? We have to look at every single one of these letters in order to know whether our DNA sequence was good or bad, right? Every single character has to be one of these in order for us to know that we were good. So there's no way that we can possibly be returning inside our loop, right? Because we won't know that our whole sequence was good until we drop out the bottom here. You know, until the loop is over. Because once the loop is over, then we know we've checked every single character, right? But on the other hand, how many bad characters does it take to ruin our DNA sequence? And that's a lot easier, right? It only takes one bad letter, right? The moment we find a singular bad letter, we know that we have a bad character, right? Therefore, bad DNA sequence, okay? And we know that we can return false straight away, okay? Now, it doesn't really make sense to have an empty if and then an else, right? I mean, we could do this, and that is technically valid Python, right? But it's really clunky. And what we would prefer to do is to sort of invert this whole argument here, right? And then return false. So I'm actually going to do that, right? We're going to get rid of this else. We're going to say that this is the bad one and return false. And we're going to flip all this logic here. So we're going to say not equal to, not equal to, and not equal to. Okay? But you got to be careful here, right? Because this isn't actually the opposite of what we just had in, right? You can look up, they're called De Morgan's laws. But basically, when we deal with ands and ors, we have to be really careful about flipping them. So if we think about what this one says, it says if C is not an A, or C is not a T, or C is not a G, or C is not a C, okay? And if we think really carefully about this, that's actually every single letter, right? Because let's imagine a scenario in which C is A, right? Then sure, C is not an A is going to fail, but if C is not an A, C is also, sorry, if C is an A, C is not a T. Okay, so regardless of what letter you pick here, one of these is always going to be true, and therefore they're all going to be true. So whenever we flip a bunch of statements that are ORed together, we actually need to change these guys around to be ands. And now my thing has gone slightly off the screen, so I am going to be real sneaky here and get rid of one space so it all fits on one screen. Shh, don't tell anyone. Okay, so if our character was not an A, and it was not a T, and it was not a G, and it was not a C, then we know we had a bad character and therefore should return false. Okay, that's easy enough. But now if we think about it, once we get to the end of the loop, if we looked at every single character and none of the characters we looked at were bad, then we must have had a good string, right? So we know that if we manage to get to the end of this loop without returning false, then we can return true. Okay? And this is a very common structure you'll see, right? A for loop, where every time we have a check that could possibly end the loop, and if we make it to the end of the loop, we know that the opposite was true. Okay? So in other words, pretty straightforward logic, in the sense that if nothing bad happened, it must have been good. Okay? Now we did have one other thing we had to check there, if I go back to the problem, which was it must also be a multiple of 3. Okay, now we handled that before in the leap year tute. I think that was the first tute. So we know that we can check divisibility using this guy, the modulo. So we want to check if the length of the string that we've been given is divisible by 3. So in other words, if when we take the modulus of it, we get a 0. Okay, now in that case we have an invalid DNA sequence, so we should just return false. Okay, now I see a lot of people they try and put something like this, and you know, maybe they put it inside here, or maybe they put it right down the bottom, or anything like that, right? But if you think about it, this is something that we only really need to check once, right? Like the length of the string is not going to change as we go through and do our calculations. So we really should just do it right at the start, right? We should do simple check right at the start, and then we can actually avoid doing all of this sort of computer work, right? When we don't have to. Okay, imagine we have a DNA sequence or, you know, potential sequence that we're checking that's millions of characters long, right? It's a lot easier than to check every single character and then finally get to the end and be like, oh yeah, by the way, it's also not divisible by 3, right? We should just do that first, and then we can chuck away half our cases immediately. Okay, so what have we got here? We got a couple options. Is DNA balls? Nope, false, right? We've got some invalid characters here. Let's check cat. Oh, well, that's false. Okay, so I have muffed something up here, haven't I? CAT, that should definitely be 1. So what have I done here? For C in string. So if length of the string mod 3 is equal to 0, oh, return false. So of course I've done this one precisely backwards, right? If it is divisible by 3, we should be returning true. But like I was saying before, we can't necessarily do this, right? Because we know, just because we know that the string is multiple of 3 doesn't mean it's a DNA sequence, right? We still have to check all of this stuff. So I'm going to flip our logic again. If it's not divisible by 3, we want to return false. Okay, so if we got one that's not divisible by 3, we want to return false. So let's chuck cat in again. True. Let's chuck cat with another T. False. Okay. And let's also check something else, just to check that lowercase t. And that's going to be false as well, right? Because we've specifically checked for the uppercase t. Okay. And so there's no reason for us to, think that the lowercase t should also be considered here, right? Because we've specified these 4 characters. Okay, so that seems to be working. Let's look at the next one. The reverse complement, okay? So our reverse complement is going to take one argument DNA. Okay, and what we have to do here is computed by interchanging A's with T's and G's with C's and reversing the string, okay? For example, the reverse complement of AAT, yada yada. Okay, well we can see that the AA has gone to the back and become TT. T has become A, G has become C, A, T, C, G. Okay, cool. So basically we're swapping out all these characters and then we are flipping the string to reverse it. Okay, and we got this little tidbit at the end. If the sequence is invalid, return none. Okay, well let's start with that because that's quite easy, right? We just wrote something that tells us if a sequence is valid, and it's this isDNA function. Okay, so if our isDNA function is not valid, we should return none. Okay, so let's check if it is not valid. Okay, so we can always just chuck a not in to reverse our condition. Okay, if not is DNA, we want to, I think it said return none. Yep. Okay, well that's the first part out of the way. Now that we know that our sequence is valid, we should be able to construct a valid valid reverse for it, right? So when we're sort of dealing with strings in Python, right, since strings are what we call immutable, you can't individually change the characters of a string. Often when we're doing a problem like this, we want to start with an empty string, right, and then build it up from nothing. Now, in terms of what I'm saying about the other thing, with strings not being able to be changed, you can have a bit of a go with this as well, right? If I have some sort of string, right, I can access individual elements of it, okay? But if I actually try and, and turn this from stringy into, I don't know, springy, Python will say no. Okay, we're actually, oh wait, oh, whoops, that was a bad example. If we try and turn it into springy, there we go, Python will say no. String object does not support assignment. We can't actually physically change what's in this string guy. So if we want to reverse this and make a complement, we actually need to make a new string and build it up. Okay, so let's just start with this, and what we're going to do is, I guess we're going to loop over every single character in the old string and figure out what its complement would have been and build up our string that way. Okay, so once again I'm going to use the for in loop. So for every character in our DNA sequence, well, I guess here we've got a fairly sort of, a kind of boring task, but a very easy way of doing it, right? Is that we can just check if the C was an A. Then what do we want to do? We want to add a T to our sequence, right? Because A and T swap out. So we can just build up our string. Remember strings also work with the plus notation to glue our strings together. So if our character was an A, we want to stick a T on the end, right? And then if our character was a T, we would want to do the opposite and put an A. Okay, and then 2 more here. Oh, I just know I'm gonna make some typo in here and it's gonna come back to bite me later. And G. Okay, so we should have a reverse guy at the end of this. And let's actually just see what we've got at this point. Print reverse. Okay. So if we put in a sequence and it's a valid DNA sequence, reverse complement, oh that's a long name, so let's put cat in. So let's think about this. So the first one's a C, right? So it should give us back a G. Then the A should turn into a T, and the T should turn into an A, okay? So I hope you guys remember what those three characters I just said were, because I don't. But G, T, A. Oh yeah, cool. Okay, San Andreas Live. Sweet. So we know that these three characters are working for us. But we do have to remember that we didn't want this, right? This isn't really the reverse at the moment. We sort of just got all the complement characters. We actually wanted to flip the order on this. Okay. So how do we flip the order on this? Well, to do that, I'm going to have to show you guys something that it's called Python string slicing in Python. Or sometimes I like to call it splicing if I'm feeling edgy. Okay. And you would have seen this in some sort of form. If I have my testy string, right? You guys should know by now that we can actually index the individual characters starting at 0 and sort of view them individually. All right. Now we know now that we can't change those characters, but this notation actually extends a bit further than you might be aware, right? So I can give it 2 arguments. And in this case, as opposed to it just being the singular character, it's the character to start with and the character to go up to, but not including. Okay? Because if we just think about this over here, I'm just going to... Okay, 0, 1, 2, 3, 4. Okay, so there's our characters, right? So if we go from 0 to 3, it's saying grab the 0th, 1th, and 2th character, but not up to the 3rd character, right? So we get this TES back. Okay, similarly, I can, start anywhere I want and slice from there, right? So we're slicing up our string. Okay, it's worth noting that in this notation, if I leave either the start slot or the end slot empty, Python will fill out the rest of the string. Okay, so from here, we're going from the first character just all the way to the end. Okay, whereas if I do the opposite and I put my 3 here and I say empty this, it's saying start at the beginning, right? Which is the same as putting a 0 in there. So that one's a bit less popular. And something else that you might have to do one day is if we want a complete copy of our string, we can just put in colon, like with blanks. Okay. Now there's actually a third argument we can chuck in here by adding another colon. And this last guy here is called the step. Okay. So if we have some sort of string, right, we have the start, the end point, and the step. Now when I say the step, I mean how, and sort of what increments it's counting, right? So when I said here 0, 3 before, there's actually kind of an implicit 1 in there, right? Because we're going 0, then we're going to 1, then we're going to 2, then we're going to 3, right? It's sort of, we're not up to 3, we're going up to 3, but not including 3. But if I put if I put a 1 here, right? It's exactly the same as when I just had the empty colon, because we're going in character steps of 1. But if I say I want to count every second character, suddenly we're only getting every second character, okay? And when it comes to reversing our string, right, we can actually set this step to be backwards. See how it's counting there? So to completely reverse a string, keeping everything intact, we're saying we want the whole string. So we say from the entire start to the entire end, counting in steps of -1. Okay, and then we can see how we've got our testy backwards. Okay, so let's chuck that in over here, right? So we didn't want to get the reverse back, right? We didn't want to get this part of the string back, right? We wanted to actually reverse the whole thing. So in that sense, we wanted this guy. Okay. Now, I believe that was actually the end of the function. If the sequence, then we should return the reverse complement, okay? So I'm actually not going to print this guy. Let's actually turn this back into a return. But that's a really good way to sort of debug your function as you go, right? Chuck in a whole bunch of print statements and check along if your variables are what you think they are. Okay, so let's run this. Reverse complement, do I have one of those? I've got one up here. And let's look. So A is from the T turns into A turns into T, and then C turns into G. Okay, so it looks like this guy's working. I guess we can give it some longer ones. Okay, so this should look like 3 T's, then 3 G's, then 3 C's, then 3 A's. And there we go. Okay, so that's our reverse complement function right there. So the string slicing sort of aspect we've got there is a very powerful thing in Python when it comes to handling strings. So it's best to know exactly how it's working and what each of these 3 guys are when you're constructing your functions. Okay. So that is our first two there. So let's look at the last one we've got here for this DNA section. Printing codons. Okay, so DNA sequence is divided up into blocks of 3 letters. Okay, well I guess that's why it has to be a multiple of 3 in length. So we've got GAT, TAC, AAA. Okay, those are our codons, they're called. Write a function print codons, which one by one prints each of the codons of the sequence. Okay, so def print codons takes a DNA sequence. If the sequence is invalid, do nothing. Okay, well, I guess we're going to add that same bit of code we had last time, right? If it's not a DNA sequence, so remember we're calling isDNA and we're saying we want the opposite of that, right? So if it's not the isDNA sequence, then we want to do nothing or return none, I suppose. Okay, otherwise we want to print out these codon blocks one by one. Okay, so this is actually going to be a really useful time for us to use that slicing stuff I was talking about. Because if we have a bit of a play around here, right? Let's get a codon. Cat. Oh, actually, I guess that's kind of boring. Cat, GCT. So if we wanted the first 3 characters, right? Now remember we wanted what? So the first 3. So we want 0, 1, and 2. So we go from 0 up to, but not including 3. That gives us the first characters. Cool. Now the next codon is going to be from 3, 4, and 5, right? So 3 up to 6, and then 6 up to, but not including 9. Okay, and that's the end of our codons. Okay, so we want to be able to set up some sort of loop where we can grab these 3 characters each time. Now we can see here that it's just increasing by 3 each time. So let's just start with well, what's the first one we're going to get? We're going to want to start with a 0, right? Now, if I is 0, what do we want to print out? We want to print out our DNA sequence. Okay, now, if our index is 0, we want to go from I up until, well, let's just think about what we're doing here, right? We want 3 characters, right? So whatever our index is, we want the next 3 characters. So we go I plus 3. Okay, so let's just quickly run this and see how we're going. Print, whoopsie-doodle, codons. Cat. And you see we got our cat, we got our first codon, right? Now, but if we want to get all of the codons, we're obviously going to have to loop here, okay? Because we don't know how long our DNA sequence is. So let's set up a while loop. Now, I'm not entirely sure what the condition is here at the moment, so I'm just going to put true here. But while it's true, we would want to print our sequence, right? And then what do we want the next thing to be? Well, we want to then increase by 3 to get the next 3, right? So we would print, and then we would I plus equals 3 to increase our I by 3. Now let's just try running this one again. Oops. So that looped for a long time because I told it to loop for a long time. But maybe if we can just grab up where we were here, we can see that, yeah, we definitely got the first 2 codons, right? But my loop's running forever, so it's just going to keep doing that. Now, we actually didn't get any error messages while that was looping. And that's one of the sort of good and bad things about slicing in Python. If I have some sort of string, and I want to slice, and I say, oh, cool, let's go from the 52nd character to the, I don't know, the 89th character. Python doesn't really care. Python's like, oh, you know, I couldn't find any characters there, but it doesn't actually sort of shit itself and give you an error message. It actually just goes along with it and says, oh, cool, you want some weird characters, I won't give them to you. Which can be useful in some situations and unuseful in some situations, right? Because if it had crashed there, I probably would have had a better time of figuring out what was happening. But let's just think here. We want to go up until our I is what? Well, I suppose it doesn't really matter because we can keep going as long as we stop, right? But we would want our I to be what? Strictly less than the length of our sequence? Whoops. Len of DNA, right? Because once we get to the end, we want to stop printing, right? Yeah, there we go. Cool. So we got our 2 prints, cat, and done. So I will be 0 the first time. Then I will be, what, 3? And then the moment I hit 6, that is not less than the length of our DNA sequence, right? Because our DNA sequence is 6 long. So then it stops. Okay, so I guess when we're done here, we would just, well, we're done, right? We don't even really need a return statement. We were just printing in this example, I believe. yeah, which one by one prints each of the codons of the sequence. If the sequence is invalid, do nothing. Okay, so if it's invalid, we're doing nothing. Otherwise, we've just set up a little loop here to print as we go. Okay. Okay, sweet. Yeah, okay, cool. So I'm actually going to call that part 1 for the moment. Stay tuned for part 2. As always, if you've got any questions, chuck them down in the comment section, and I'll be back in a sec to see you guys for part 2.